Okay, and three.
It's already started.
Oh, it's already started. There you go.
All right, here we go.
Well, good evening. This is Pete N6QW out here on the left coast. And I'd like to start off by saying thank you for the invitation to speak to your group. It's really a joy to talk to homebrewers because first off, you learn a lot, and secondly, you can experience the joy because you can see people face to face. You know, when you talk about something, you see somebody light up and say, "Oh yeah, I understand it." And of course, I also shared with me how many of you built the LBS, which was probably QRP Quarterly told me that was one of the most successful articles that they've ever had because of the number of people that were actually building it and they had feedback on it. So it was a very successful project. I'd like to start maybe first with my approach to homebrewing, and everybody does things. A little bit different, but the way I start is I try to build everything in modules. And the idea being is you get the module board, and typically, I'll start at the back end. I'll start with the audio amplifier. So if I can get the audio amplifier to work, then I can check that block. And then next maybe is a product detector. So there's a way of testing the product detector with the audio amplifier. Then build the IF stages, and you can inject signals in there. So now I know the IF stage and the product detector and the audio amp works. Then you add the receiver mixer, and then get that to work. So this way, you're not building everything at once and then saying, what's wrong? Why doesn't it work? The other thing too is I like to always think of my projects as an experimental platform by building things in modules. Let's say you build an audio amplifier module and you see a new chip, a new audio chip, and say, man, I'd like to try that. So you just decouple that module, put a new audio amplifier module chip in there, and then test it out without destroying the whole radio. You know, if everything's all on the single board, the first thing you do is you start burning wires and burning parts and components. And so I always keep in mind that I want to use my projects as an experimental platform. And using modules, that makes things pretty nice. The other aspect is to try to keep everything at 50 ohms. This way you can swap things in and out. If it's 50 ohms, it just plugs together like a Lego box, like things such as mixers and IF amplifiers, RF amplifiers, and what have you. So kind of that as a basis, that's what I typically do, and that's how I typically approach it. And one of my projects, the KWM4, which I published in QRP Quarterly, kind of the last end, it said, when you have a design team of one, you sometimes get stuck because you don't have anybody to talk to. You have no one you can confer with. So collaboratively, that's why this group is so nice. Is if you got a problem, you can throw it out here and say, hey, have you looked at this? So that's really good idea that you have a homebrew group because then you can share the knowledge and share the information if you're doing this all by yourself. So what I'd like to talk about this evening is one of my latest projects, and that's a software-defined radio. And of course, the thing that's most significant about homebrewing today is this is the golden age of technology. We have so much technology available to us at our fingertips, and it's so inexpensive. And I'm talking about a $35 Raspberry Pi 4 for 35 bucks. I mean, this is a powerful computer that can do all kinds of things. And you have things such as the Arduino. I've been buying Pro Minis for $4 a piece. And you add an SI5351 breakout board to that at about 8 bucks. You add an encoder, and you can add a LCD display that you buy for 99 cents. Next thing you know, you got a digital VFO with 2 VFOs built in it with an LCD display, and you have change left over from a $20 bill. So we live in a golden age of technology. And the other thing, too, is the YouTube videos and the internet. If you don't know how to do something, just go to the internet, type it in YouTube, and somebody has done something with this. And I'm just totally amazed at how the availability of it. I was buying some color TFT displays. Well, this is before the tariff went into effect. $4 delivered to your front door from China. $4 including shipping. you know, 65,000 colors in a 1.8-inch color TFT. I mean, that's a lot of bang for your buck, and you know, sometimes the shipping is more than what the product costs. So we live in a great time, and the time is right to look at building the software-defined radio. Now, I should tell you, of those 40 plus transceivers, just a few are really SDR. And I built my first SDR transceiver about 3 years ago, where I took a soft rock and I connected it up to a Raspberry Pi, and that was the subject of an article in QRP Quarterly. So that was one, but it was a little complex because I just didn't have a good understanding of what I was doing. And you know, you had to get smart on this. It's not just a matter of hooking things up. But fast forward to today, and now my website, N6QW Radio Genius. Please excuse me for using that
I like it.
as a website. But I got tired of people poking at me, so I said, okay, I'll show you. I'll pick that name for a website. And in that website is really two paths. One path is to take some of the existing boards that are available, like the soft rocks, if you can find some of those. I don't know if anybody's bought one of those boards, but they were like 60, 70 bucks a couple of years ago. Now the Ensemble, which has replaced that, which is a 3-band board, if you get the kit version, I think it's in the $80 range, something like that. So the website shows you how you can take the Ensemble board and essentially turn that into an SDR transceiver. Now the other piece of that is the displays. You know, before you had the big old clunky displays. Now you get a 7-inch HDMI display, touchscreen, for about 50 bucks, and that'll give you enough resolution you can see the whole spectrum on it, and you have all the functionality. A small Raspberry Pi, small sound card. I mean, here's something that'll fit in a briefcase that you can take with you, you know, on a trip, or take it into the field, what have you. So you no longer have this big clunky computer like, you know, initially with the soft rocks were run with the Power SDR or the big old computer. Now you got the small little form factor Raspberry Pi that'll fit in the palm of your hand. It's really dramatic. So let's talk a little bit about what is an SDR. There are 4 components to the software-defined radio, and this was how I started the article in QRP Quarterly here about, actually goes back almost 8 or 9 years ago. That was the first article I wrote on this. The 4 pieces include the radio itself. Then you have some sort of a sound card, because we use the I and Q approach versus a DDC. They have the computer itself, third piece, and the 4th piece is the software. So 8 or 9 years ago, you had Power SDR and you had a big old desktop computer. Now you have the Raspberry Pi, takes care of that. The sound card is a $15 device that you can buy, and the sound card essentially takes the signals out of your receiver board, and the I and Q channel, which is in phase and quadrature, they're at audio frequencies, and are processed through the sound card. And then the Raspberry Pi does all the heavy lifting, and a piece of software called Quisk, Q-U-I-S-K, written by Jim Alstrom, N2ADR. This is amazing because you get the control panel, you get the waterfall, you get the functionality of band selection. You have things such as bandwidth. I mean, you can set the bandwidth on sideband 200, 2000, 2.2, 2.5, 2.63. CW, you have 200, 400, 600, 1K. It'll receive AM and FM, so it's really amazing. But the 4 pieces are now at hand, and the sound card's 15 bucks, the Raspberry Pi is $35, the software is free, and then the radio, if you bought the Ensemble, you're paying about $85 or so for, or so. Then you need a USB frequency controller, and the USB frequency controller is sold by a company called SDR Kits in the UK. And the bare kit without the SI570, which is the frequency control, is $15. But you can write Silicon Labs free SI570 as a sample. And Circuit Labs. I said, can I get a sample? They sent me 4. So these things are 16 bucks a piece in small quantities. So a lot of this stuff based on engineering samples, you know, you can get the stuff free. And I was just upfront with them. I'm building a software-defined radio, and when I was done, I sent them an email with a picture. Said this is where they went. So they were happy. I was happy. But the thing is, my website has several links on it that tell you how to load the software on the Raspberry Pi, how to set up Quist, and actually the three or four links that are there are in conjunction with an article that I wrote for a magazine that comes out of India called QSX, and I told them, here's the article, but you can't put all that information in the article, so I said they can go to the website, and so it tells you how you load it. But even now, they've got later versions of the software. It's much easier. The website just has the more powerful version of the Raspberry Pi as the image. So you just download the image, and you get a piece of imaging software and load it on the SD card, and you're in business. I mean, 5 minutes, you essentially can boot up the computer. But let's talk a little bit about how the software-defined radio really works. In its purest form, using the I&Q approach, I have 2 direct conversion receivers. Each ADE1, which is a double bounce mixer, is an independent receiver. So the incoming signal off the air goes through a little old FT3743 ferrite core that has 8 bipolar turns on it. And the common goes to the bandpass filter, so essentially you're splitting the signal into 2 received signals that are at frequency 90 degrees out of phase. So that one signal goes into one ADE1 on the RF port, second signal goes into the second ADE1 on the RF port. Then you take the USB controller, which produces the local oscillator signal at 4 times the signal frequency. And the reason it's 4 times is you run it through a 74 AC74 dual D flip-flop. And what happens is when you run it through that flip-flop, it slices the signal by 4. So if you're going to operate at 7 megahertz, you have to put 28 megahertz in. But also coming out of the IC are 2 signals that are 90 degrees apart. So one is in phase, the other is a quadrature. So essentially you put one of the signals into one of the ADE1s, and you put the other signal into the second ADE1, and coming out of the IF is audio. So it's demodulated audio. So you have an in-phase channel and a quadrature channel. And then what I do is, because direct conversion receivers are very prone to noise and hum, I run those through a modem transformer. And I should tell you that I was not a genius about this. I went through Hans Summer's website and saw that his QCX transceiver, anybody have a QCX in the group?
No, not yet.
Yep,
There's
Q.
a couple.
Couple.
It's got 2 modem transformers in there. That's what he did. So I said, that's a good idea. So I just lifted it and put it in the mine. And it really works very well. So then you get the I and Q channel. The I and Q channels are then fed into the line input on the little $15 sound card. And that's done through a relay. And the reason that's done through a relay is that I use this as not only a direct conversion receiver, but a direct conversion transmitter. So when you go to transmit, the signal coming out of the sound card, and it's like a case of sideband reversal, where you have the local oscillator above the frequency, you get the sidebands reversed. So what you have is a crisscross on this little relay so that you invert the I and Q channels on transmit. Otherwise, you'll receive a lower sideband and you'll be transmitting an upper sideband unless you do that reversal. So little relay does all that, and then it works back through the system. Now, the ferrite core transformer is a splitter on receive, but on transmit, it's a combiner. So it takes the 2 signals coming through the transmit way and combines them into a single signal into the low pass filter. And the low something more than just two section. You need a three section there because you need to make sure you're not getting any out of band signals with that mixing that's taking place. Make sure you've got good solid 50 ohms. So the website shows you do some of the bandpass filters for various bands that I've been putting rigs on. So now once you have this demodulated, then the Quest software takes over, and it gives you the spectral display, and it lets you look at the waterfall. And I should tell you, and let's digress for just a second. Having built so many transceivers, it's more heavily weighted into the hardware side with crystal filters. I got to tell you, once you start operating an SDR, you don't want to go back. You just don't want to go back. I mean, the digital filtering, the being on frequency. I mean, I don't know. I try to discourage people from building 4-pole crystal filters because there's kind of a real science to that, and often guys just take 4 crystals, slap them in there, and say, "Yeah, it sounds like crap." And let me tell you, so you don't have to fool with that. Yes, 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 absolutely. So, um, I try to use package filters as much as I can, and I have a few rigs with some four-pole filters in it, and I just can tell the difference. By and large, the other thing that's nice is normally the default on boot up with Quisk is like 2.8 kilohertz. For some reason, these guys that operate the Flex like the 3 kilohertz wide signal. I mean, you don't really need a 3 kilohertz wide signal, but everybody seems to default to the 3 kilohertz. But what's nice is you'll hear something off to the side, put it down to 2.2, it's gone. It's absolutely gone. And that's what's so nice is, and I should tell you that I have a kind of regular communication with an RF engineer. Matter of fact, this guy used to live in Newbury Park where I live. He now lives in New Mexico, and he's got a lot of really good test equipment. He has looked at the received signal, and he tells me it is really good. So I mean, if I some of the filter rigs that I put on here, and he'll say, yeah, you got a little lower, you got a little upper sideband there with the lower sideband. It's not quite doing the job it should be doing. So I mean, there's a lot of heartburn, and if you've listened to the Solder Smoke podcast, Bill and I go round and round. Bill is hardware defined radio, and I'm kind of now shifted to the software defined. But once you listen to it, and there's just a sweet spot, and the thing is, you can calibrate the SI 570 so that it's right on frequency. Well, I should tell you something. I got to be fessing up here. There was a guy with a Flex 6700 that was listening to me, and he said, "I just want to tell you, you're 14 hertz off." He had a rubidium frequency standard locked to GPS, and he told me, he said, "You need to fix that." Come on, guys. I mean, when I first started out, if you were kilohertz off, it was okay, with 14, you're 14 hertz off. But just think about it. We have equipment now that can tell us when we're 14 hertz off. I mean, it is amazing. And it's within the realm of possibilities that you can have that in your shack without spending thousands and thousands of dollars. So I think comparatively, the software-defined radios do much for us. And I think they do much for us in terms of signal handling capability, the signal processing, the ability to really separate signals. I think what I like too is now some of these, like the Flex 6700, will look out 15 kilohertz. I mean, 15 megahertz, excuse me, 15 megahertz. So screen pops up, and if you're on, tell if anybody's on 40, or anybody's on 75 meters. So it's really amazing. Now, the most that I can look at, it depends on the sound card. I have one sound card that lets me look at 100 kilohertz. Most of the ones I have, the $15 ones, let me look at 48. But 48 kilohertz, when I look at it, I kind of hang out in a certain area of the band,
and that 48 kilohertz covers pretty much where I want to hang out. So you can see signals pop up, or you turn the rig on and you don't hear anything, but you look off left or right and you see the signals popping up. You know there's signals on the air, which makes it kind of nice. So I think it's a wave of the future, and think about it. The software is free. It's running on a $35 computer, and so that's what's so nice about it. As a matter of fact, I found out something here. I have an old TV set that was a 19-incher that we replaced it with a larger size, and I had it sitting in a corner in the garage, and then I realized it's got an HDMI port on it. So I mean, you could pick one of these up at a garage sale for $5. Someone says, "Who wants a 19-incher?" and I get a 54-incher. That works. That works with the Raspberry Pi. So I mean, you don't have to spend a lot of money getting monitors and what have you. Say I want keyboard and mouse for $10. Works terrific, and it's big enough for my fat fingers that I can still work it. So I mean, you can acquire this hardware pretty inexpensively, and the thing is the actual physical electronics is pretty small. It's pretty small, and so you don't have to worry too much about. Like I built the KWM4 transceiver. It took me 3 months to build, and that thing has got tons and tons of circuits. And boy, when something goes awry, you're scratching your head. It's much easier looking at SDR. There's a 4x6 card, and that's it. So it's pretty easy to figure out what's wrong, what area is wrong, and go after it. So I think in terms of maintainability now. Bill makes a good point. He said, I want to know what every capacitor resistor is doing in the circuit. I've moved beyond that. I know what resistors and capacitors do. What I'm more interested in is looking at, can I see the signals? Can I hear the signals? Can I process the signals? And is it a good quality? And that to me, I think, is where the hobby is shifting. And as homebrewers, I think, because of the availability of the technology and the things that are available to us today, it's amazing, and you don't have to spend a ton of money. A little judicious shopping will get you what you need. Like I found my original Radix board had 2 modem transformers in it that I paid, I think, almost $5 a piece for. I then found 5 on the internet for $4. So that's the kind of deals that you just need to take your time and look at it. But I'm just inspired by it. The other thing I'm inspired by is the single board computers. The Raspberry Pi is a really good deal at $35. And actually, I haven't played with a Pi 4, but I have several Pi 3s, and they work just fine. Matter of fact, I even got it to run on a Pi 2. But the Asus Tinkerboard, now that's a really interesting machine. That's a 1.8 gigahertz. It's got 2 gigs of RAM on it. It's the same form factor as a Pi, so you can put the Asus Tinkerboard right inside of a Pi case. But it's faster, and I can tell the difference. In other words, when I run run with the Asus Tinkerboard, and while we're at it, let's talk a little bit about FT8. In some circles, you talk FT8, people get all nervous in that. Anybody run FT8 in your group? There you go. Oh yeah, okay. Well, if you take Joe Taylor's software and you download it to the Pi, you go into your file manager and you click on it and says install, and you just click on it and it installs it. Boom. That's all you have to do on the Pi. It won't work that way on the Tinkerboard, but on the Pi it will. And then once you get that, you've got all the functionality that you could want. I mean, the Pi with the Quisk, with the Joe Taylor software, you're instantly on digital, and you're it's really cool because I use Whisper a lot just to see band conditions. Like I get up in the morning and 4:30, 5 o'clock, I'll turn Whisper on, and then I can see if the Far East is open. If I'm starting to see Whisper stations, it's a good time to get on 40 meters to try to make some contacts with Japan. But I mean, there's another free download, WSJTX, and there you are on digital. Now I have operated digital off of some of my other hardware radios, but I had to design a digital adapter to be able to do that. You don't need a digital adapter. It's right there inherent in the Quest software and the Raspberry Pi and the and Joe Taylor software. So it's really kind of nice. I'm just totally amazed. Of course, you feel a little disconnected with FT8. I mean, it's like kind of, I always call it like remote sex. You click on it and the computer takes over and you're not involved. You know? Suddenly you got a report and says, "Hey, 73s, have fun." I see some other people share my opinion of what it's like. But I mean, it is something, and for some people, it's a mode of operation that otherwise they wouldn't be able to do. I mean, I know some guys that live in an apartment that have a mag loop, and suddenly with FT8 and running 30, 40 watts, they're able to work DX. So, that's really wonderful because it has opened up an avenue for them. But I mean, the digital is only getting better, and I guess there's an FT8 call. Has anybody used that where you can actually put message? Anybody ever use FT8 call? You have. So you can actually type in messages. So it's more like a QSO then. Oh, okay. So there you go. I mean, as the stuff gets out there, people say, "Hey, it'd be great if we could do this." So here we go. There, it's going there. So I think um, the problem is that I think a lot of people want to take on home brewing, and they're doing it with an engineering team of one. And this is why this group is, I think, so great, is because if you want to take something on, as I look around the room, I can see a lot of resident experts to be able to help you to be successful. I mean, I had one guy says, "I've never built anything. I want to build your KWM4, which is a dual conversion multi-band transceiver." I said, I said, "Do you have any test equipment?" He said, "I have a VOM, you know, and that was it." And I said, "I don't want to discourage you, but you're not going to be successful because it takes a little bit more than just a VOM and a desire to build something." And I said, "Start small, start with the Michigan Mighty Might, start with a direct conversion receiver, then kind of work your way up that you can do that." And there's some really good simple kits. Like, I mean, I don't know how many contacts you can make with a Pixie, but that would be certainly something to get one of those and just get some experience soldering. I mean, if you blow it, I think you can get the Pixies now for what, $3-4 from China. I think they're in that realm. So, if you're, and that's the other thing too, is you've got a lot of money invested in the kit, and then you see the smoke. The smoke test is it goes up in smoke. you know, so I think starting small, but if there are more groups like this, such as yours, that'd be wonderful. That'd be a wonderful place. Any newcomers, this is the place to start because I, I've soldered my fingers together 1,000 times, and I've been at this for 60 years, and there's still a lot of stuff I don't know. And if you're starting out and have a desire to do something, start small. Start with projects that are reasonable and attainable, and then you can move on to bigger things. But I also like the idea. Davey, you were talking about group builds. That's really good too because then you also have a standard of performance. If yours works better than mine, I want to know why. And then you have an opportunity to learn to figure out why yours works better than mine does, or yours works and mine doesn't. I'll learn why. So I think that those are some of the important things. I'm encouraged also by the fact that the available technology puts things in your hands that you never had before. Like there are test instruments. For instance, anybody in the room got an Antuino? Anyone get Farhan's Antuino? Yeah. Or Wayne's got a Wayne's got one. I was given one. Farhan gave me one because he gave Bill one, he gave me one. So I was lucky me. But I got to tell you something. That's the slickest thing ever. I built a bandpass filter. I, I I do a lot of simulation on LT Spice. I love LT Spice. I put LT Spice together, did the simulation, and I looked at the graphs, and it was perfect. I put it on that, put it on the Arduino, and didn't look like anything in the graphs. So then what I was doing is I said, wait a minute. So then I compressed and squeezed some of the cores, and I got the inductance just right on those ferrite core inductors, or the yarn powder ones. And then the Arduino looked like the simulation. So I mean, it was great because you can measure it in the simulation, but the real world is a lot different in terms of being able to see it. And I mean, now I put bandpass filter on there. I either spread the turns or compress the turns. And the other thing too is the values of these components that we get. Boy, you got to watch that. I bought a bag of capacitors from China. Not one of them are the values that's printed on the face of the capacitor. Not one of them, and they're worthless. I mean, and two, you think about 20% spread, a 100 picofarad beforehand. You can't just make the assumption. So that's another thing, is that the issue of being able to not only design something and simulate it, but also to be able to test it in the field. And that Arduino does a really credible job. And I have an SNA that I got from Dwayne. By the way, Dwayne, if you're listening, hi. Uh, he and I, yeah, he and I email all the time. As a matter of fact, just the other day, but I was lucky to get one of his SNA juniors, and that's a very useful piece of equipment. So I mean, there are many test instruments and test devices out there that let you, when you finally build something, you get a chance to see, is it really performing as it should be. And the other thing is the digital storage oscilloscopes. Man, I got to tell you, that's got to be the world's greatest invention. And when guys tell me they want to take up homebrewing, I say, look, save your pennies and get a scope, because you won't know where you're at otherwise. So it's really important that you have some good test equipment, and you have a plan. The other thing too is getting enough information. I guess I always say in a lot of the articles that I've written, the last thing you do is turn on the soldering iron. The first thing you do is gather a lot of information and really get smart about what you're doing, where you're headed. And the same thing with these SDR radios. I should tell you that I built an SDR radio here about a year ago, based on Charlie Morris's design. Anybody look at Charlie Morris's ZL2 CTMs? Yeah, that's a nice radio. As a matter of fact, I built one based on his design, and I had a few problems. One of the problems was I was not getting the opposite sideband rejection. And now, based on what I know, I think I know why. And I talked to Charlie about this. It may actually need that reversal that I had to put in the Radig. That he uses the same kind of relay thing, but I'm not sure that you aren't getting a sideband reversal, and that's why on transmit it sounded like it was coming out on upper sideband when you were in lower sideband. But the basic board that I built for Charlie's project is the one that I modified, that I'm using on the Radig that you see on the website. I did add the modem transformers. I talked to Charlie about the possibility of hum, and he didn't have any hum issues, but I did have a hum issue, so I put those in there, and the modem cleared that up. So I mean, there's some really great work by some very clever and innovative people. I mean, I got to tell you that it's just amazing. And I guess the first time I saw something similar, Charlie, was from somebody in Canada. A VE6 or VE3 used a teensy and everything else and put that together. I'm not sure who that is, but there's a lot of interesting work, and I just took the easy path. I put a Raspberry Pi instead of putting the teensy in there, and so hats off to Charlie, because he wrote all the software to make the teensy work. But anyway, we live in a great time, great opportunity, and again, it's wonderful that you have this group, because it affords people, and we need to get some young people into the hobby. we need to get them off their iPhones and get young people into the hobby. I mean, as I look around the room, I think I'm probably the oldest one in the room, but I got a few with gray hair too. So we're kind of like we're seniors at this, and we need to get some young folks. Although I did see where some work being done by in England, UK, with the GQRP club and Hans. Matter of fact, they have the Youth on the Air, where he put that group, and matter of fact, that's where he kind of semi pre-released the QSX was with this group. It was all these young people. The other thing that's interesting is YLs. There were a bunch of YLs in there that really knew what they were doing. So that's kind of good for the hobby too. So anyway, the website has a lot of information. If you're interested in getting some more data or detail, my email address is there. Be happy to share what I know. And matter of fact, I have on the blog today, I just uploaded on the blog some information about the final amplifier that's now on the Radic. Initially, the final amplifier was an IRF 510, and that produced about 5 watts. And on my n6qw.blogspot.com, I have detail in there how I modified that to put one of the Mitsubishi RF FETs in there. And the modifications are really simple. I just took an LED and I lifted one of the pins on the regulator, and so I raised the voltage on the bias voltage regulator, and just the pins are different. Where you have on the IRF 510, you have the pins from left to right. Looking at front face is the gate, and then you have the drain, and then you have the source. And KB1GMX Allison recommends cutting that drain pin off and then making the connection to the tab. That's a really good thing. I just pulled that out of there and put the Mitsubishi RF FET in there. And the thing that's nice about the Mitsubishi, the tab is the source. So you don't have to put an isolator kit in there. You can screw that right down to your heat sink, which makes it kind of nice. So you get a direct contact. And there's a photograph on the blog that shows the picture of the RF amplifier. And it's good for about 6 watts. Now, the benefit of the Mitsubishi versus the IRF 510, if anybody's used an IRF 510 like at 17 meters or on 15 meters, you'll find that output kind of drops off, whereas the Mitsubishi is designed as specifically as an RF device, so you can get a good solid 5 watts out of it, and that's one of the reasons why I made the change. So anyway, I talked fast. There was a lot of information to be covered, and again, thank you for inviting me, and I'd certainly like to open it up for any questions anybody might have. Yeah. Yes. Yes. All of the above. Yes. And now the thing is, this cost about $4. So they're not cheap. I mean, I've been buying RR 510s for 69 cents. So you buy a whole box, you smoke a few and say, yeah, not a big deal. But the RD series now it does need a good heat sink because the idling current is pretty in transmit is some of it's about 300 milliamps. So you're really heating that up, but it's very linear. That's one of the reasons. And so it works really, really well from that standpoint. I've gotten good signal reports with it, and I've looked at the output, so it's pretty clean. Right. Yeah. I'll share that with you. First of, um, I build all my circuit boards on a CNC. Okay. I'm fortunate I have a CNC, and I don't know if you know the story. I'm going to digress for a second here and share with you about my $250,000 CNC machine. Okay. And the reason it cost 250,000 is uh, that's what it costs to send my son to engineering school. He's a mechanical engineer. So in repayment, he said, "I'm going to build you a CNC machine." So he did. So he said, "Here, we're we're even." So that's why I call it my 250,000. The only reason you pretty much need a circuit board, and I yeah, can you hear me? Can you? The $250,000 CNC machine. Okay, but to use the device, the Talo detector, would be you'd have to design a circuit board to do that. And while I'm pretty good at designing stuff for the CNC, I'm not real good at designing circuit boards. And I wanted to try the concept with the ADE ones. And um, I got into a little discussion with someone that says you should use the Talo detector. Forget those ADE ones. Well, it works just fine for me, and there's only essentially four connections. The LO port in, the RF in, the IF out, and ground. And the Talo detector, and then needs no voltage. I mean, these things are essentially passive devices. So I've used them. I've used them successfully. They work fine. But for someone that wanted to do a Talo detector, yeah, why not? Yeah, you see the signals in and out, and you don't have to worry about. Well, he's actually scanning at. It's not only quadrature; it's 90, 180, 270, etc. And you get those ports and summing them. So I just did it an easier way, and to me, it seems to work just fine. Well, don't scrap it just yet. Okay. I happen to have HDSDR on one computer because I had a board, an Omnia SDR that I bought a couple of years ago, and it's designed around HDSDR. There's one functionality in HDSDR that is very useful with the Quisk, and what that functionality is built into it is a way to zero the SI570. So what I'm able to do is I'm able to, because it's essentially soft rock based, I'm able to connect the my USB controller into the HDSDR. And what I typically do is I'll look at the WWV and I'll figure out how much it's off. Then I plug it into the computer with HDSDR, and then I'll say make this correction, and that's how I program the proper chip. Now, evidently, I missed by 14 hertz because because the guy with the GPS told me I was off 14 hertz. But I thought that was pretty close, 14 hertz. But the HDSDR, I got to tell you, the screens are a lot different in the Quisk, and you have a lot more information. I didn't find the HD SDR to be as user friendly as the Quisk. The other thing that's I wanted to share with you about Quisk, which is really important, and it may be somebody in this room. When you download Quisk, embedded in that is a way to turn certain of the receivers that or transceivers that work with Quisk into a VNA. So when I go into the run and I type in Quisk, it gives me a choice of Quisk or Quisk VNA. And the VNA panel comes up. It's spectacular. I don't happen to have the it's got to be the Hermes Light that you use. But the Hermes Light, not only do you have an SDR transceiver, but in use with the Quisk, already built into it is the control panel and the interface to turn the Hermes Light into a vector network analyzer. And the Hermes Lights are like about $300. So having a high-powered vector network analyzer for $300 in free software sounds like a good deal to me. Oh yeah. There's the guy with the GPS. There you go. His rigs are not off by 14 hertz, are they? Yeah. I work. That's Fred PE0FKQ, whatever. He wrote that software. That is really a slick piece of software to be able to calibrate that stuff. So I keep. By the way, I found out there's a guy by the name of Cecil Bayona, and Cecil still sells the ATINY 45 microcontrollers program with the latest. So if you're looking, if you got something that's defunct, you say, where am I going to get one of those? I just got some from him, and they're a couple of bucks a piece. So you check out Cecil. He has those parts if you're looking to get the microcontroller to run the. And I know they work because I put them in the SDR kits, and it works just fine. So that stuff's still floating around. No, I haven't, but I guess the current approach is the direct digital conversion, so that there is no I and Q channel, and they're just doing conversion from from the analog to digital directly. And I assume that they're doing the same kind of thing with the sampling, but I'm not familiar with that technique, and I've not tried that. All my work has been pretty much limited to the audio using the stereo cards, the I and Q. So I have not done anything with it. Okay, I have an Omnia SDR that has a built-in codec right in the SDR, and that lets you look at 96 kilohertz. Now, the Quiz software has built into it selection of bandwidths, and they include 48, 96, and 192. So that 192 is in the software. So if you have a sound card that supports it, Quisk will look out to 192 kilohertz. Yeah, like I said, the Omnia, I can see twice the bandwidth that I can on some of the other rigs, but I don't. The sound cards I have, I paid $15 for, so 48 is fine. you know. Yeah, all that works great. The only thing I didn't like about the Xfinity is the cabling. The cabling uses some. It uses some of the 3.5 millimeter, but also uses the RCA. So you got all this jumble of cable. It'd be nice. It'd be nice if they were. I mean, it works. It works really, really excellent, and it's kind of a weird shape. I mean, it's not a square box or anything, and it kind of is always flopping around the desk. Physical things, not performance of the card. So the card is very good. Well, I'll tell you the one that I thought was superb was the M Audio Delta 44. I've got two of those, and I spent $150 a piece for them. And I don't know what I do with them now because they work with the Power SDR, but I haven't tried them on any of these. I've got two of those, but you need to install them in a computer. So I mean, the little sound cards I'm using now are just standalone. They're plug-in. Yeah. Yes. Well, that was another thing I investigated, and thank you for bringing that up because that was one of my notes, and I kind of went over that. I investigated DC to DC converters, and Meanwell sells a very inexpensive, anywhere from 9 to 18 volts in, will produce 5 volts at 3 amps out. So that's perfect. Hook it up to the 12-volt battery, and now you got the only thing you got to worry about is the 5 volts for the Pi. So now you got 5 volts at 3 amps will run that Pi off of a 12-volt battery, and as the battery voltage drops, it'll work all the way down to 9 volts. No, but I'll tell you this: the Pi 4 needs a bigger supply. I mean, I'm running some 3 amp supplies, and for the Pi 3, they say that's kind of marginal. The other thing is you got to pay attention is cooling. You cannot just put a heat sink on that thing. They're fan assisted because they run hot. They're really cranking away. So I took the Raspberry Pi cases, the plastic ones, and I did a Mark One Mod One modification. I cut a circular hole and I got some little fans that came off of CPUs mounted on the top. Solved the problem. Well, I bought a box. And the box, I paid 35 cents a piece for them. So I bought a lot. So I still have some in the box. So, oh yeah, just put it in there. There's no reason why you can't use some other techniques other than relays, but the relays make it kind of easy for me because I usually use them dead bug. I just glue the top down with some super glue and then make the connections and you're off and running. So there's no technical reason why you'd want to use those other than I have a box full of them and I paid 35 cents a piece for them. I have. And here was the issue. It wasn't an issue. It's just that the Quist software is got built into it. In other words, as you tune it, the tuning dial moves. I substituted the SI 5351 at 4 times into the port, and the thing is, nothing's moving on the screen. It's working fine. I mean, you're receiving stations. It's just that you'd have to use what display you'd have with the SI 5351. Technically, it works. It'll tune it. It's just you get nothing on the screen. So you have the functionality. I mean, you can because everything is downstream out of the board. You essentially can get the bandwidth changes, the changing the specific operating band, what have you. It's just that it's not in sync with you're not seeing the cursor move on the screen. And no, and so I've been doing some work on that. If I put a lot more time into it, you should get a flatter response. It's kind of a domed response. You should get a flatter response. Oh no! What? Yeah, what you would see, it drops down by about 3 dB, so you'd get about half that power. So if you had about 5 watts, you'd be seeing 2.5. Yeah, yeah, yeah. It's a little more work. Yeah, it needs a little more work, but primarily my interest was 40 and 20, so it works fine in there on that. But when you get to 15 and 10, it takes a little more design, I think, to really give you a flat response, so that you'd say, okay, it works from 80 to 10 meters and it's flat. I just possibly both. Yeah, yeah. By the way, I should share with you. Uh, get signed up for Sprat. There's another transceiver project coming down the pike. This one is not SDR. This one's got a filter in it. He's using an SBL one. No, the SBL one, they both have a conversion loss about the same. The reason this is really weird, and I must apologize because I'm sort of running close on time. Um, the ADE ones, if you bought one, was $16. If you bought 10, it was $4. If you bought 12 of them, you could buy 12 ADE ones for the same price you could buy three. Threes would be $48. A dozen would be $48. So of course I said, okay, I'll buy a dozen. So when I built it, I happened to have a stock of ADE ones, and that was the reason I used them. But the SBL one, essentially their same device. Right. Thank you. I mean, this is so great to be able to talk to homebrewers. Terrific. And I hope I answered your questions. And there, you read the website, and if there's some things that you have questions on, be delighted to answer anything for you. And good success with your homebrew projects. I mean, I think this is great because you got this group of people here that have a common interest, and just you all learn off each other, and you end up with a really good product at the end. So congratulations. You